So, hello, I'm Izzi Smith. I'm the SEO and UX advisory lead at Ryte. We are a website user experience platform, but I've also worked in-house talks like this, and I also am a fan of cheesy jokes and memes, so you might see some of those dotted throughout the talk today. And one thing I've been working a lot on this year is helping our customers at Ryte achieve a strong, positive user experience on their website. So not only having the means to a powerful SEO to increase their organic traffic, but to, of course, ensure that visitors are converting and engaging with the content and being retained as a loyal user. And a great place to start with that is by measuring and improving your core web vitals, which, for the sake of getting all of us on the same page here today, are the three metrics that you see in front of you: largest contentful page, first input delay, and cumulative layout shift. I'm sure a lot of you at home have already been working on them. You're already well aware of what they are, but let me just quickly introduce the three of them for you. If you hear a weird grumbling noise, that's my tummy. I didn't have breakfast or lunch yet, so I'm a bit hungry. Don't be afraid, all good. So first of all, we have LCP, largest contentful pane, which reports the render time of the largest image or text block visible within the viewport. So in this instance, it's the polite cat image there. So as a page loads into view, like what we see in this trace here, the largest contentful pane element will keep changing. So it's a great way to know, this metric is a great way to know when the above the fold, so the most critical content and information, has reached a relevant frame. There's very easy ways of identifying the largest element, but I'll be showing you that very soon. And on the initial slide, I mentioned it's usually the largest image or text block, but it could be a header, it could be any kind of HTML element that you see here. So this was a really nice study carried out using HTTP archive data that found that the majority of the largest contentful pane elements are caused by images. And the second one we have is first input delay, which helps estimate and measure when a user can first interact with a page. So they can properly engage with the elements there, they can tap, they can see a response, they can, move around basically. And to describe first input delay, I need to walk you through this nice little handy diagram here, because in general, input delay happens because the browser's main thread is busy doing something else, so it can't yet respond to the user's interaction. And one common reason to cause this is the browser being busy parsing and executing like a large JavaScript file that needs to be loaded in order to support the page's functionality. So here on this diagram, I don't know where I'm pointing or where I am. Here on this diagram, you can see the browser processing those network requests and becoming these main thread tasks down there. And when these are being processed, those yellow tasks, it results in periods where the browser cannot respond to any incoming requests. So if someone taps on this link or this button during that time, they will not receive a response. First input delay itself measures the time after the user interacted and how long the main thread was busy for. So imagine here, Joey is the server, there's the interaction, and with this delay of, let's say, 400 milliseconds, we're giving the response. And this would measure the first input delay. And finally, last but not least, we have cumulative layout shift, which helps quantify unexpected changes and shifts on the page. And it also helps us quantify how visually stable a page is. So let's say we have our polite cat sticker page here, and then you go to click on read more, but all of a sudden the free shipping banner shifts, it appears and shifts everything down. So you end up clicking on buy now instead, which is super frustrating. I am using a lot of Brewdog examples today. That is a really cool craft brewery from Scotland. And here, when you click onto the page from the SERP, there's a lot of shifts going on. So it can be very visually unstable. And core vitals themselves are also part of Google's page experience metric. They go hand in hand with other UX and performance metrics like mobile friendliness and safety issues that Google is really focusing on to improve the state of the web. Now, these will also contribute to ranking signals as well, which in theory shouldn't be too strong, but recently this nice study by Systrix released this September uncovered from their data set that they could actually conceive an actual measurable ranking signal from this. So it does highlight another important reason to get our optimizations underway, not just to improve our user signals, to decrease bounce rates, exit rates, and to improve conversions, of course. And I know it's difficult. There are so many other important topics that deserve our attention, especially in 2021 alone, we had focuses on mobile-first indexing, more aspects from the page experience update, 2 core updates, many core updates, the recent title changes. There is a lot going on. So I understand if there hasn't always been such a strong focus or the ability to make some decent changes here. But that's why I'm here to help. So hello, I've been carrying out lots of research in this area, and today I want to share that all with you. So first of all, I got to thinking, how widespread are these issues? Are websites struggling with improving their core vitals and their performance? Is it just a handful of smaller domains that are problematic? So I got to investigating. And I used a number of tools to do this analysis. So I've been using Chrome DevTools and Chrome Lighthouse in order to first assess the page performance and any sort of significant issues going on here. Now, with Chrome Lighthouse, I'm taking a look at lab data, so synthetic data that is reproducible based on a set of configurations. And I'm also using PageSpeed Insights because here I can also take a look at field data. Now, field data is based on how actual real humans are coming across this page and what kind of experiences they're having. So big differences could be that with field data, you do require a lot of interactions in order to have a good, confident result there. But with lab data, it's not the actual picture, but it's far easier to reproduce. And based on this mixture of Lighthouse, PageSpeed Insights, and I'm also using Ryte, the Ryte Web Vitals report, which is crawling websites using Lighthouse and then retrieving all of this data in bulk, all of these granular scores for each page at the time of crawling. So I'm not just passing in one page at a time. That would take forever. With a Ryte crawl, I can see the entire picture of the whole domain. And I found some pretty surprising results that I wanted to share with you today. In my first study that I carried out at the beginning of this year, with a focus on Germany, Austria, and Switzerland, with a focus again on e-commerce, just to really narrow it down, I analyzed 114 of DACH, Germany, Austria, and Switzerland's top e-commerce websites. And next, I also did the same in the UK. So the top 112 e-commerce websites there, and ran a sample crawl. You can find all of the detailed results in our Core Web Vital study that I did together with our data science team. And again, the results were pretty shocking. So not a single domain reached a good performance score on mobile devices. So on desktop, the scores were okay, but we focused in the beginning on mobile just because of the sheer importance and gravity mobile experiences have on an overall search representation. And here are the average scores that you can take a look yourself. So I even thought that the UK domains would do better than the German domains, but the average performance score for the UK ones were significantly lower. And yeah, they're all not so good. And then I got to thinking, okay, maybe the scores will improve over time because Core Web Vitals is still quite new to us at this stage at the beginning of the year. And, you know, these improvements can take some time to get off the ground. So I ran a study 6 months later that focused on the UK domains. And the difference was actually worse. So it's also as a caveat, you know, I was analyzing a set of pages. So maybe I was analyzing in the second instance a worse group, but it seemed pretty similar in terms of the URLs taken. But unfortunately, things did not change, which is sad. Yes, I know. And I wanted to dig a little deeper, and that's another reason why I want to share some more insights with you to show you, you know, not just what's going on with these websites, not just for the fun of it, but to also prove to you and to help you prove to your internal stakeholders that Web Vital fixes don't need to be so painful to implement, and to show you just how detrimental it can be if you just push them under the carpet and don't take too much care there. And it's all based on real world cases today. I'm going through some causes and some cures for poor Core Web Vital scores. I did some quick analyses of well-known websites that some of you might know. I'm really not trying to name and shame. That's not what I'm doing here. I just want to also detail to you how I run my analyses, and to maybe also demonstrate that big websites and big names aren't always that good. They're not always the best to take inspiration from. And I chose 5 of those today. And I started grouping the issues I found most frequently into my Web Vital woes. So woes being avoidable problems that give me great sorrow or distress. Hope you're ready for this. There's a lot to show. Okay, case number 1 is Brewdog. I mentioned Brewdog already. I'm a big fan of their products. Their craft beer is delicious, and I'm a big fan of their ethos. And they're great advocates for things like net zero, for climate neutrality, for a lot of topics really. So I'm really a big fan of them, and I got to use their website. I have to use their website today because there are just some not so nice things happening on their site that would probably help demonstrate quite a bit. So yeah, here are the results from the crawls that I've been running. So 100% of their pages scored as poor. Let me just increase the screen size so I can see what's going on. Yes. And then what I next did was narrow the scope to their product pages, because maybe you have 100% bad Core Vital scores across your website. Maybe it's only a fraction. I hope it's only a small fraction for your websites. But in order to get executive buy-in to improve these technical issues or these performance problems, I first need to prove the fact that real money, like real revenue or business growth, is at stake here. So I narrowed it down to their shop pages, which are under these following URL subfolders there. And then I'm going to focus on a specific page template to identify structural flaws. Because if I'm resolving issues that are present on a wide number of pages, and of course that's going to be a much more efficient fix there. And we're going to prioritize based on a meaningful KPI like clicks, which I don't have because Brewdog are not a customer, and I would never show customers data. But yeah, normally you would have your Google Search Console data there and can prioritize with clicks. So I'm going to use performance scores to prioritize. And I'm going to use this random gin page today to show you the case. Most metrics were pretty bad, but we have to start somewhere, right? Also kind of interesting to point out here in the total blocking time area that 600 milliseconds is the cutoff point for bad total blocking time, and they are way, way, way above that. Now, the other metrics are not so good either, but I really wanted to focus on that today. You can now, in PageSpeed Insights, filter by which web vital you're hoping to improve. So already I'm getting hints on reducing the impact of third-party code, so I investigated this. To start, let's identify what is causing those long total blocking times and pop over to the Sources tab in Chrome DevTools. And here I can see all of the resources that the page has loaded. Now this, for those of you who aren't so used to this tab, this is a very ridiculously long list of different origins from across the web, including tracking scripts that have fired before I've even given my consent. So here's an example of how it should look like with Ryte. So when you opt in for tracking, you say, okay, I accept all, and then the tracking scripts fire. But Brewdog themselves are not being so GDPR compliant here. But let's not focus on that issue so much today. Which made me think when I saw this long, long list of third-party sources that maybe there is a lot more than meets the eye here. So let's go back to the Performance tab in DevTools, where we can visualize if there is an issue with there being too many requests, too many scripts, and basically all of this time where the browser needs to, again, process those and cannot process the user's incoming request. And look at the waterfall here. So this process of all these assets and scripts and requests needing to be processed, this is a lot. There's a lot going on here. So my first web vital woe is that there's too many third-party scripts impacting the critical rendering path. It can really easily happen that so many stakeholders get involved in website activities and they need their tracking script, they need their tool, or their advertising iframe, they need all sorts within the page. And this isn't just bad for performance, as it's taking up all that valuable time on the critical rendering path, but there could also be many privacy and security concerns too. A little handy tool to help you out with this is Built With. So you get an overview of what technologies are being relied on, so it's great to check out for your client before you've gone into too much detail. And rather than, of course, cutting out any unnecessary third-party scripts, yes, so always remove any unnecessary scripts that you don't need, of course, but the ones that you do rely on, you should defer them where possible or load them asynchronously. So it's a little bit of a difference between the two, but unless there is a specific reason not to, all third-party scripts should be loaded with either defer or async by default. So JavaScript files with the async attribute will run in no particular order as soon as they're loaded, whereas deferred resources run in sequence. So basically the order they appear in the HTML. So it is best to use defer for your lower priority scripts. Speaking of scripts, let's go back to our list, shall we? There's still more going on here. And it's not just third-party resources causing a nuisance. When we expand a URL here, it's giving me a list of all the resource and assets that are going on. And there's a lot of Brewdog's own self-hosted JavaScript and CSS files that are causing complications. And the list doesn't stop here. So not only is there a heckload of third-party resources, but lots of CSS and JavaScript files too. I actually reached 202 assets that had a conceivable file size, which is a lot. That's a lot of requests again. In Lighthouse and PageSpeed Insights, we can view the tree map using this button. And you can see a breakdown of any shipped JavaScript that's filterable by size and coverage on load. And it is a nice way of viewing bundles too. Yes, looking up here, there is 8 megabytes of JavaScript files, and over half of those aren't even being used. So toggling the unused bytes will give you this nice visualization as well. Now, 8 megabytes is a lot. That is 11 minutes of music streaming over an average quality on Spotify. And that's almost 15 seconds of the never gonna give you a video. Imagine telling this to someone who's accessing your web page on data roaming using a sketchy internet connection. That's not so great. That's a lot of data that is being transferred. And you can again see these unused scripts in the tree map viewer. You can also find it in Chrome DevTools again. Sorry that I'm switching a lot between tools. I just want to show you all the different ways you can access these insights. And then once you click on those scripts down below, so I clicked on the top one, which has 99% of unused bytes. And then we can see again in very granular detail which actual rules are not being used. You do have to have someone responsible with you, like a developer, someone who's capable of making good decisions here when you're making assumptions, because some of these rules could very well be used for other parts of the page, but it is now the developer's responsibility to assess if this can be optimized, and it almost always is. My second web vital woe then is there's no prioritization logic for these JavaScript and CSS files. There's no order involved. They're just all being shoved in. They all take up valuable time and space on the main thread. And again, this is slowing down the page load so that we cannot process the user's input again. So just showing you the nice diagram that I like to refer to. So what can we do about it? Well, I'm going to go through the process of splitting and bundling, which can help out a lot here. So here are my CSS and JavaScript files needed for the page. There's separate ones that are styling and providing functionality to different elements. And each of these needs to be evaluated, parsed, processed, rendered, etc. So in the act of doing something called bundling, we can group them together into a single file. This reduces latency and overhead on the initial load, and there's a smaller amount of requests to process. However, these files can become very, very heavy for the browser, and it often tends to lead to lots of unnecessary scripts being loaded in the first instance. So it could be rendering functionality that most website visitors won't even interact with. Let's say if it's really buried on the page. So we can employ something like code splitting, which will split files up into more logical files and then cleverly take and highlight the code needed for critical rendering and bundle those together. So then you have your critical assets needed for above the hold content and functionality, and your non-critical assets that can be requested and processed at a later stage. And this isn't too complicated. It's not too outrageous. I am by no means a developer, but there are existing module bundlers like Webpack out there that can do this. Like they can merge these modules and components that should be included statically together into a single file, and also optimize the critical assets as well. It can also be used natively with some frameworks like React. And in general, it is a very accessible optimization that can really prioritize, and optimize your web vitals. Another thing I noticed when browsing Brewdog's product pages, I know I'm focusing on them a lot, especially when I was on the mobile version of Brewdog's website, was this image slider. You see those white rectangles down there? On the image, these things that you never would have guessed provide any value. Well, this is a slider. You can then view 2 other images of the gin. Each of these images are unnecessarily heavy in file size. There's no compression, no resizing going on. This addition of that grapefruit, I think it is another 3 megabytes for your poor data plan. Yeah, I know. So my third web vital woe is that the images are, and I have a lot of image problems going on, so I had to even create a GIF to just cover some of the more well-known ones. Like, the dimensions are not specified, they're not deferred or lazy loaded, they're not compressed, they're too weighty in file size, etc., etc. And in this case, in particular, the images are unnecessarily heavy. Image optimization requires its own 3 hours of talking about, so I'm only focusing on a few areas here today. Maybe next year that can be the next topic. Which takes me to the next case for Lush. I love Lush, again, another company that I do admire. They have great products and commendable values. And they have a lot of visually appealing products. So naturally, they need to show these off with the usage of high quality images or even GIFs and videos. Now, this can be very challenging for performance metrics. So last year, I did a study of theirs in my first Core Vital talk, and I identified quite a few issues. Some of them, they've actually improved over the year, which is great. So here's the status last year in December. And then at the end of summer this year, they've made quite a good improvement. So from 7% of poor pages and 70% needing improvement to a very nice 66% being good. Let's see what they resolved mainly. In the first instance, I focused on their product and store pages. Again, ones having high business value, a lot of people visiting these on their mobile on the go. And this large image of this hero image of the store itself had a file size of 5.4 megabytes. Why? It's just huge. So the loading times were very low and could be improved. So I focused on reducing the largest contentful paints here. Now that they have updated the pages, the storefront pages have been reduced to 150 kilobytes. They're still good quality, it's the same image, and this has led, alongside probably some other minor improvements, from a performance score of 8 to 71. There's still some things that they could resolve on these pages, but the difference is massive. Another thing that they improved was they previously had ingredient lists tucked away on their product pages because ingredients for them are very important to show for their organic ethos, but each of the ingredients had its own unoptimized and undeferred image. This was a big mistake because all of those images needed to be loaded despite the fact visitors would rarely even click open this menu. All of the product detail pages had these, just like this bath bomb that had 23 unoptimized images tucked away on the page. Again, not many people are going to see them. And what did? They just removed the images. Sometimes it can be as simple as this. Like, I was recommending them to just lazy load them. So only load the images if someone scrolls them into view or interacts with the element. But they just thought, hey, what is the point? We have the names there. Let's just remove the images. Okay, fair enough. Here's some 6 quick tips that, based on my analyses of many websites, would help your image optimization. I won't go into too much detail today because, again, there's a lot to get through. But using an image content delivery network will speed up the delivery. Oh, sorry, the text is being cut off there. I will improve this when I send out the slides. Always compress the images. Providing image dimensions really helps with layout shifts, as the browser is aware of how much space should be reserved. Using modern formats like WebP and AVIF. SRC set really helps with responsive images, and also preloading hero images, those large central ones there. Our third case is Halfords, which is a UK brand for like car parts, bike things. I would never go into this store because I'm not a big fan of transport. I can't drive and I can't ride a bike, so it's not my kind of place. But yeah, it's a very well-known chain in the UK who are also struggling a lot with their web vitals, especially cumulative layout shift. Now, CLS is normally less than 1.0. It's from 0 to 1.0, but things are going so wrong here that they've achieved an all-new high of 2 point whatever and above, which is, it's a lot. So let's again see what's going on here. In Chrome DevTools, we can find all of the layout shifts and paint a better picture of the issue's gravity. And to really describe these issues to stakeholders, I like to visualize the trace and encourage them to actually use these pages and witness what is happening with their own eyes. So here, just to show you what was happening to create such a poor cumulative layout shift. In the first paint, we have a loading animation, which isn't always so helpful, actually. People would rather see at least an outline of the content elements about to appear rather than just some kind of whirring wheel there. Then they have the main navigation that appears and some unstyled text. The body copy is finally painted, so they see what's going on and what the price is. Whoops, sorry. The COVID banner appears up there. Apparently every website needs a COVID banner to tell you that they are caring about you and things are fine. And then an image appears of the tire. So then it pushes everything down again, and a cookie banner appears from the bottom. So a lot going on there, especially this big shift that pushed the content, the text content below the fold. So my fourth web vital woe is that space has not been sufficiently reserved for static elements. Implementing placeholders and reserving space is such a must for images and banners and text content elements that do have a chance to appear later on in the page's paint. So here I've reserved space for that free shipping banner, and then there's no unexpected shifts that push people's interactions away. React users can use something called a skeleton UI. This is what Ryte uses in our tool when reports are loading. So at least people know what is going to be populated. So that something is going to be populated with data. It could just take a couple of seconds and then it will appear, and it provides a much more seamless experience. And a given at this stage is providing image dimensions. I just mentioned this as part of the image optimization part, but it really helps make sure that the browser is reserving the required space there. And you could also use something called aspect ratio boxes with CSS that can, in certain cases, help avoid those shifts. The fourth and a very quick case is Mindful Chef, which is a grocery box delivery service like HelloFresh. Also struggling here with web vitals, and they have something called a flash of unstyled text, which does contribute towards cumulative layout shift. And now that's where the text is styled without the desired end font, and then the user sees a flash of this, and then it can shift because especially with different fonts, they have different widths. And so it's gone into a new line. It's changed the box ratio and everything. So yeah, I actually kind of prefer the fallback font here, but that's a question of taste, I guess. And you can locate those flickers within the film strip back in DevTools under the Performance tab. And just locate when the font files are being downloaded and executed, and optimize by making sure they're being preloaded. Another problem related to that is the way they have this really stylish crafted background image that was created just for the homepage on mobile devices, even though they forgot to account for the text, the subtitle text overlay there. This background image is 4 megabytes, but that's another issue regarding images, so I would really compress that. but this image is taking a lot longer to load and process again. So my fifth web vital woe is that critical assets are not being preloaded. In other words, moving them higher up in the render queue to ensure that they are being loaded before non-critical assets, because these are the most important for the page's first render, especially for the critical assets there. So this would look like you're preloading the image as image and the font as font. There can, again, be quite a quick and easy solution. But try to avoid preloading too much. The browser does a good job of identifying cases where you've preloaded assets that aren't actually used within the first few seconds. And you shouldn't preload too much again, because then there is no priority whatsoever. Whew, okay, so I got a little bit exhausted at this stage. There's a lot of bad cases, so let's have a nice success story, shall we, to finish up the talk. So finally, I want to show you Ryte's new homepage. We are slowly, or not slowly, it's going well. We are gradually relaunching our website into a new design. And our new Web Vital scores and our performance scores are going really well. So let's take a look. First of all, we have relaunched to use the Next.js front-end framework using React and server-side rendering, which is a given for any JavaScript-heavy applications and single-page applications. It's also kind of nice that the Ryte software is using React, so we have a lot of talented developers in-house that can also help us create the website as well as our fabulous software. But to optimize our setup even more, we're using Preact as a React alternative. This gives us the same functionality, but with a much more lightweight solution. And according to my developers, it reduces the amount of data that needs to download the page load by 20%. And apparently the implementation was pretty easy. So that's quite a good win. Font optimization, this had a really good impact. Actually had an impact of 5 to 8 performance score points, according to the developers, which is really cool. We are hosting our fonts on our own domain, and we're using the highest compression standard, the best data format, so WOF2, which is automatically compressed, and also using font display swap and preloading it, of course. I will hurry up as I know I'm running out of time. I'm almost done. And we're using a tool called User-Centric to take care of our consent management. And this plugin is very convenient, but the consent screen was the largest contentful pane element. And this can happen to a lot of websites. So in order to improve this, we are only loading the consent screen if we witness a human interaction. So you can see the JavaScript list of events there. So a mouse down, a mouse move, a scroll, etc. And then when we register that it's a human interaction, we will then fire the consent plugin so they can accept or deny. And via the link field, we are preloading fonts and files. So we're telling the browser that we need these files, better start downloading them now. And when the HTML is already being executed, the file that's needed to style whatever is already there. And yeah, you can, of course, preload this in the head, but we found it's much faster for us, especially because of all the Next.js files we have in the head to implement this via the link HTTP header. Again, in general, it's good to avoid preloading too many assets, but this worked pretty nicely for us, as well as caching everything, including the HTML doc. We're using a very nice CDN setup using CloudFront, and this had another great impact. So finally, as a little wrapping up statement, my Web Vital woe number 6 is assuming that Web Vitals can be resolved all alone, whereas actually it is an outcome of working really together with your web developers, your UX team, and creating this high quality on-site experience. So here, with the Ryte team, we're lucky to have some really experienced developers as well to support us with this. And getting the process running, you can take a look at this in your own time, and you can take a look at the checklist that I've added at the end there. Thank you, everyone. And I want to wish you the best of luck with all your Web Vital optimizations. And I hope you have a much speedier and more satisfying experience in general, yeah, in the next years and months. Thank you.
Hi, Izzi. Thank you so much. It was an amazing session.
Thank you. It was a lot of fun.
I hope you will get breakfast after that.
Yes, I'm getting my lunch now. Yeah.
Okay, we have a few minutes, and we have a few questions. We can check the questions if you like. Okay, first one from Samet. Hi, would you suggest we use priority hints, for example, high, low, and auto?
Yeah, I remember our developers have been working with priority hints as well. Like, I don't have too much information on there, but I think these will have I can also check in with them and get some more insights for you, because I wasn't so involved in this implementation. I am just the messenger for the good news. But let me check in for you, Samet.
Yeah. Okay, thank you so much. Then, what are the advantages for HTTP 3 when you compare it with HTTP 2 protocol? Can you elaborate on the differences between these two?
So HTTP 3 is really gaining traction, especially with more availability across like CDNs like CloudFront, Cloudflare. Actually, I don't think CloudFront has availability yet for HTTP 3. But this is definitely the best standard to be using if you do have access to it. It is more secure. The data transfer, has more security. It is also faster. And I would also recommend checking out Tom Anthony's talk on HTTP 3 versus HTTP 2. You can just search Tom Anthony, HTTP 2, you will find it. It is a much better explanation than I can ever provide you. He is like one of the great technical SEO minds, so do check that out.
Okay, thank you so much for the hint.
Sure.
And do you believe AVIF format provides better compression on images compared to the WebP formats?
So there's been some really good comparisons recently of WebP versus AVIF. I do believe AVIF can be a much better image format for things like icons, illustrations, where you don't need so much of this like pixel perfect quality, because the file size is much better compressed, or can be much more better compressed than WebP. But also the quality for things like high quality photographs can be lost a little bit. So do compare the two of them. There's a really nice tool called Squoosh. Squoosh is kind of funny, where you can add in your image, and you can play around with WebP and AVIF and see which one is providing the best quality and the best image file reduction and compression as well. So that's really good to play around with.
Okay, thank you. Yeah. Just keep in mind Squoosh, right?
Squoosh, yes. So SQUOOSH, like Squoosh.
Okay. Yeah. Thank you so much.
Sure.
And then another one, what can we do in the database optimization process to improve TTFE?
I'm sorry, I am not so good in database optimization. I would have to ask my backend developers to help me out there. I'm sorry, Emery. I'm more of the front end support.
Thank you so much. And from Cengiz, thank you very much for every information relevant with user-friendly search optimization. Thank you for watching us.
Thank you.
Thank you, Izzi. It was great to have you at Digitalzone 21. I hope see you in person maybe next time.
I hope so. Thank you so much for having me. It was a pleasure. and have a wonderful rest of the day, everyone. I'm going to go get some food.
Please. Thank you so much. Bye bye.
Bye.